audio production. We thank for the gift of Mr. Hudson Taylor to us, and that he has been working with Christian broadcast, Christian recordings for a long, long time. And we thank you, Lord, for the gift of him. We thank you for all the students who will be hearing him today and learning certain techniques in and through him. We pray that you bless our university, Karunya, and that all the staff who work there, and especially during these times, bless their families with good health of mind and body. We praise you and thank you, Lord, for all that you have been to us and that you would be to us. And we pray for ourselves that we will always be loyal to you, faithful to you. We make this prayer through Christ our Lord. Amen. Okay. So I would like to introduce Hudson Taylor to you. Now, Hudson Taylor has been in this field for more than 20 years. At least I have been with him for more than 15 years now. And he is a visiting faculty at Xavier University, Bhubaneswar, where he teaches audio production, digital audio production. And he was also teaching earlier when we had a center at XIC Ranchi. He was also teaching there. And he sets up studios in number of places. He has set up quite a few places, whether it is Ranchi or Bhubaneswar, Xavier University. And he is quite good at acoustics. And he is both indoor and outdoor audio recordings. It's a very difficult combination that you will ever get to know people who are good at both indoor audio as well as outdoor audio. And certainly I have experienced with guys who are good recordists and then probably people mixing. But there is someone who can explain that. I think he is the only one I have found. He was on my staff in Loyola Academy, Secunderabad. I brought him so that he will teach people, because many don't understand that audio plays a vital role in filmmaking or whatever you want to do in production. Audio plays a very major role. Most of us don't think about it. Most of us don't even reflect on that. We don't think the animation and some of these techniques that you know to use will bring a good production. No, good production comes when your audio is good. So therefore, we thought, Dr. Malika and I thought we will bring someone good to teach you, or rather speak to you, so that you can also get to know the techniques in audio. You can certainly ask about any software. He is quite good at it, and he will teach. He will, in fact, speak to you on certain basics, and then you can, depending on the type of students we have today joining, they can take it to another level. They can ask any type of questions. There is no problem. And as I know, he is really an expert in this. And some of you know Joyce Meyer Ministries. Joyce Meyer Ministries, he was the sound engineer. And he has also done quite a few with SP Balasubramaniam and number of people who come to Hyderabad. They do the live recordings using the different DAWs. So let us hope that we enjoy this session given by Mr. Hudson. So welcome, Hudson, to Karunya. Thank you for accepting this offer. Thank you.
Thank you, Father. And on behalf of Department of Media and Communication and Digital Sciences, on behalf of our faculty members, HOD and staff and students, I warmly welcome Mr. Hudson Taylor, and we are indeed privileged to have you with us today, because we do not really get experts in the field of audio to address our students. So without wasting any more time, I request Mr. Hudson to please carry on with the session. You're most welcome, sir.
Thank you very much, ma'am. Thank you, Father, for the invitation. So I'm happy to be here talking to students about the audio. So I really do not know what the students are expecting from me today, but I would like to share some of the basics of the audio. Since I've been told the students are the freshers and all this in this line, so I would like to share some of the basics of the audio. Meanwhile, actually, I'm trying to connect the whole thing through my computer, where we have created a little presentation and some pictures and all that, and then also a small little DAW, digital audio workstation. It looks there's some kind of a problem. Meanwhile, I'm connected through a phone, but I will try my best to connect through a computer. So meanwhile, we will be discussing few things. Then we will go ahead and then we'll see how we can connect to that. Okay, so the first thing is the moment we talk about audio, uh, we talk about. I mean, one of the most important things. The moment we say about audio, there are only two things which comes to our mind. One is the songs that what we hear, and maybe somebody's speech or presentation. This is one of the important thing. But at the same time, when you starts to dig in, or when somebody goes to a concert or goes to a meeting, they come with, most of the time they come with a complaint saying that, okay, the audio was not good, or it was not clear, or XYZ issues and all that. So then also we find many people talk about their audio systems at home. They talk about music, they talk about the technology which has been used, like the Bluetooth speakers and the Bluetooth headsets, and the kind of when you talk on the phone, they talk about the clarity of the phone and so on and so forth. So how does these things work? I mean, how do we really get to know how does these things work, and what we have to really understand from this? So the point is here, we have to understand. I will go through some of the basics of audio here. What is the audio, or what is the sound? There are many theories behind this, but one of the uh, actual application, or the actual theory behind sound is produced when a particle is vibrating. So these are we'll just run through some of the basics. So a particle vibrates, then the sound has been produced. So let's say take a guitar string, or let's say a blade, or let's say any sound that we hear. The source will be the vibration. So now the vibration is the cause for any sound to be produced. At the same time, the sound has been transmitted from that particle vibrating to a person's ear, or to a distance, is through a medium. So this is the medium we call it as in the air, especially. It uses an air molecules as a medium, and then the sound travels from one point to another point. Now now here we will understand that sound has been produced. For example, somebody is playing a guitar, so you are able to listen to that particular guitar sound because of the air molecules have been helping us to reach to that sound. Now the speed, now we have to understand there are certain parameters we have to understand before we really can go into the deep into the sound. So this the one of the important thing is that the speed, how speed the sound travels in air. Somebody is playing a drum, so the vibration of the drums, how speed it is coming to us. All right, so that is normally about 1134 feet per second, or 330 meters per second. So that is the speed of the sound. But at the same time, the speed of sound, everybody says that, and then of course this has become a general tendency that everybody has this particular sound, it's traveling at the speed, so they calculated that. But sometimes does it really affect us in every manner, every place and all that? Not really. We have to consider the where the sound, I mean, because it changes because of the temperature, it changes because of an altitude. So we have certain, how do we get these figures into the consideration? The point is here, the sound is transmitted at the sea level, because the sea level is, it has one constant level where we consider of an altitude, and the temperature, mostly about 34 degrees, they say it as the temperature which the sound travels at that kind of a speed. So as the temperature increases and decreases, the sound also keeps on increasing and decreasing. Now, so the second thing is about the sound is about the frequency. I mean, how do we define? For example, your mother calls you in the morning to get up from your bed, or your father shouts at you since you have not done something and all that. So without even seeing them, how do you identify? This is my mother's voice, this is my father's voice, or even on the phone, you'll recognize somebody's voices like that. You'll recognize songs. So this is basically because of the frequency, of course, which registers in our mind. So the sound travels in the air with about 1134 feet per second, and then it has certain frequency. Frequency is nothing but the number of basically the vibration. For example, a string, when you pluck a string, it is vibrating for 10 times per second. Means it is called, basically the units for the frequency is hertz, Hertz. So it is about 10 hertz, we call it as, right? So if the string is vibrating at 20 times, 20 hertz. If the string is vibrating at 1,000 times, we call it as 1,000 hertz or 1 kilohertz. So what we understand is, so when we have this kind of a frequency and issues and stuff like that, we have to understand the other factors like, so what is the frequency that the human beings can hear? So human beings can hear from 20 hertz to 20 kilohertz, which means that 20 times, if a particle is vibrating for 20 times to a 20,000 times per second, that's the frequency that we can hear. Some animals, they can hear lower, some animals, they can hear even the higher, that will go up to some 30, 40, 50 kilohertz also. But the human beings can hear from 20 hertz to 20 kilohertz. That too, a good human being. I mean, a guy who's healthy, who's having a good ears, that person can only hear. Because of the pollution, what we are going through, especially in metropolitan cities and all that, the frequencies that, especially the high frequencies that are there from about 20 kilohertz and all that, we don't really hear them. We are normally, people say that it's been restricted to 16 kilohertz, not really beyond that. And then as you grow old, these kind of problems also occur, that you'll not be able to really hear that kind of a sound. Now, another issue is when we have, so we know that now we know the human being can hear from 20 hertz to 20 kilohertz. Sound travels at this thing. So what we understand, actually, I'm trying my best to connect to through my laptop. Still gives some kind of a issue and all that. So what we try to do is, what happens is, when we do this, when we try to understand the sound, the point where the whole thing has changed, or nobody's really bothered about this in the early days, but the whole thing has changed when we started to record this. It all started with the Thomas Alva Edison. By accidental, he'll be chopping the wood, and then he'll be singing that Mary had a little lamb and all that. So it'll go and then stick to that. I think you know the story. So that's where recording started, and the people began to understand how the recording can be done. Now, so the sound has been produced from from a particle which is vibrating, and then we hear the sound from 20 hertz to 20 kilohertz, and then it travels at a speed of 1134 feet per second. Now, how do we understand this? To understand the sound, we need to capture the sound. So the capturing of the sound happens with a device called transducer, or in other words, in a simple terminology, we call it as a microphone. Right? Microphone is a device which tries to capture the sound. Of course, microphones, pickups, piezo pickups, there are different kind of other things and all that, but which almost works in a similar kind of a principle. So microphone is a one which tries to capture the sound of a person, of an instrument or a string, and then it will try to put you onto the other next application of like a microphone, and then amplifier, then your speakers, then your headphones and all that. So this microphone is a basic small little device. Actually, I prepared a lot to show you, but anyway, I will show you a small little microphone, which I got it here. So this is a one. This is a small little condenser microphone, right? You can see it, I think. This is a small little condenser microphone. This will connect to the device what I use it. So there are, so this I'm again using another small little device to connect. This is the device actually connected to my computer, hoping that this is going to work soon. Anyway, so these microphones are the ones which will connect the sound to, it'll capture the sound and it'll convert them into your other devices. Now, the microphone is nothing but it's a transducer. Transducer means a device which will help you to convert your sound energy into the mechanical energy or kinetic energy, right? So what does this do? So whenever we have the sound, we have the sound is coming in, so the microphone captures the sound and it will send the vibrations have been converted into mechanical, and that mechanical energy is being converted to an electrical energy. So the small little electrical energy which has been converted from the microphone is being sent through an amplifier, and then it will be sent into your multiple applications, or for your recording, or for your public addressing, or for whatever the things that you wanted to do it will be doing that. So there are basically these microphones. There are three types of microphones that we find. One is called a dynamic microphone. Another one is called a condenser microphone. Another one is called a ribbon microphone. So what I'm using right now is a small little condenser microphone, right? So this one is the one which helps us to capture the sound. So the dynamic microphone, the moment we call it the dynamic microphone, means it is basically got a small little moving coil inside. So the coil moves up and down inside that small little thing here in this, inside that. And then whenever I talk, the sound will go in and hit the membrane, and then membrane moves, and then there'll be a small magnet inside, and then there'll be a coil. So the coil will be disturbing the magnetic flux. So the magnetic flux, whenever the magnetic flux is being disturbed, according to the Maxwell's theory, the electricity is produced in the coil, and then the coil, that little miniature little voltage, whatever it creates, that will be sent into your amplifier to amplify that to be a big sound, and then we'll hear it on the speakers or on your headphones and all that. So these are the basic three kind of a microphones. So when it comes to the condenser, instead of a moving coil, you will have a small little plate, or rather it's a plate which we call as a capacitor. It's also called a capacitor microphone. So there are two plates in the condenser microphone. One is fixed, another will be moving. But here, because of the movement, there'll be no coil as such like a dynamic microphone. But the changes happens. Basically, it's nothing but the change has to happen in the way, or the variation should happen in the electricity. That's what we are looking at. So this variation happens because of the condenser microphone. The one plate moves like this up and down, and then there'll be an electric charge inside. So this electric charge basically gets into the condenser microphone through a battery powered or from an external device. So that's the power we call it as a phantom power. Normally it will be about 48 volts and all that. You can see it here. There's a red color button which shows for this microphone. So whenever I'm talking, this is a microphone, it shows up that, right? So that's what it's trying to do. So it needs a charge from an external source to charge these two electrical plates, and then whenever you speak, one of the electrical plates move towards inside and outside, and then discharges the voltage, and then that will be carried into your cable and into your amplifiers and so on and so forth. So this is the second type. The third one is a ribbon. A ribbon also works in the similar principle like a dynamic, but there'll be two, like basically it's also called a horseshoe microphone. So early days they used to have like literally like a horseshoe, like a U-shaped magnet, and in between they used to be having a carbon granule, a fine carbon granule micro membrane and all that. So whenever you speak into the membrane moves, and then it disturbs the magnetic flux which is there in the two magnetic fields and all that, and that one will create, again, it will disturb the magnetic flux which has been created around the magnet, and then that will be carried through the coil into your amplifier. Now amplifier is another. Now we keep talking about, there are certain things that we hear mostly about like microphone, amplifier, equalizer, speaker. These are the terms that we hear the most. Amplifier is a small device which will basically, for example, from a microphone like this, when I'm talking, what is the voltage it's creating? It's very, very negligible. Sometimes even your multimeters can't really show that little voltage it shows. I mean, you need to have a very good multimeter to do that. 0.03 millivolts, small, very little, less than a voltage, less than half a voltage. It produces that little current. So this little current cannot really go and then operate a speaker. So for that reason, what we do is we try to use another a gadget in the middle to amplify that. Take this small signal and then make it bigger. So that's what amplifies. It amplifies the small frequency sound into a bigger one. And then it sends the signal to another device called, again, another transducer. That's what we call it as a speaker. Speaker exactly works in the opposite direction of your microphone. Microphone, when we talk into the microphone, the membrane vibrates and it will convert that sound energy into an electrical energy. That electrical energy will send to the amplifier. Amplifier makes your little voltage to a bigger voltage, and then it will send into a speaker. Now the speaker takes that energy, and then it tries to vibrate. Rather, it tries to work on an opposite direction like a microphone, and then try to produce that sound, whatever we are trying to. It's trying to reproduce the kind of a sound what we are trying to say into the microphone or whatever it is. So this is the basic simple structure of the sound which we hear on the speakers. So whatever you speak on the microphones, that kind of a sound, it will be amplified and then you'll be hearing it. So this is a simple basic structure of the sound reproduction. But when we get into the professional lines, right, we find we need to dig deep into it, right? For example, the microphones. So microphones, what's a microphone? How do you identify a microphone? Most of the time people say by looking at a microphone which is like this, like a small pencil, they'll say it's a pencil or it's like a condenser microphone. Yes, most of them look like that, but not really. I mean, all the microphones, just by looking at the things and all that, we can't really identify that this is the microphone which will work like that. Sometimes the ribbons also look like a dynamic. Sometimes the dynamic also look like a ribbon, or sometimes the dynamics looks like a condenser. So you just can't look at, by looking at the microphones, we can't really identify what type of a microphone is this. But as you work in this line for a quite long time, you will be able to identify, okay, this is this kind of a microphones are normally tend to be, or there are some certain buttons you can see it here in the behind and all that. So there are two buttons here. One is the high pass and low pass filter, another is an attenuation. So by looking at some kind of things like this, you can say, okay, this is maybe a condenser microphone. Another one is important to understand, all the condenser microphones needs a phantom power, an external power to run them. Whereas the dynamic and the ribbon microphones, you don't need an external power to run them. So that's the one issue that we will have to understand. Another thing is, now once we come to this, so what I'm capturing through the sound through the microphones, and I'm trying to reproduce through an amplifier and speaker. Now comes the point of the recording. Now the recording, by the time we talk about the recording, yes, in olden days when it started with the Thomas L. Edison, he used to have one small little drum. I think still you'll find it in the US, some of the museums and all that. A tar drum, then they produced a wax drum, then they produced a kind of a vinyl drums and all that. So they used to, then later on they began to produce a sound. They started to produce a sound on a record, on a vinyl record, on a something like that, and it started that way. But as the time passed by, we have seen that the spools have come into the scene. Spool is nothing but a plastic tape which has iron fillings, of very fine, like a, what do you say, fine like a powder, literally very fine, like an iron powder which has been coated on that. So whenever you speak, that microphone takes that and then amplifies the signal. An amplified signal will be sent to a small little reader, a recorder called the head. Basically, the head tries to record that recorder, and then records that, or rather creates a kind of an impression on that. And then another recorder, or the head, right? It used to read that, and we call it a play head and a record head. That used to play back the same impression, whatever it's been created on that spool, and then we used to hear that sound. So as the time passed by, that from there people began to produce the digital information, especially when the BBC has contributed a lot of this early inventions in the sound, especially even the digital application. They started with that kind of a thing and all that. So when by the time it comes to digital, the computers come into the picture. So the sound, analog sound, what we hear is an analog sound that has to be converted into a digital. So it converts. So this, for example, this small device, right? This will convert your analog sound into a digital sound. So the whatever the sound which is coming from this microphone, which is getting into that one, and that is converting into a digital application, and then zeros and ones that will be sent into the system and all that. So these are the things that which are happening in the quite some time and all that. Now let's understand how we get to know, or how we start to get the grip of this audio, all the audio together in our professional life and all that. Number one, first and foremost thing is that we need to understand now. I mean, there's no point talking about the old time spools, old time technologies like the STL tapes, the measuring systems, and so on and so forth. But now we have come to the point where we try to directly record something onto your computer, and 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 uh, and then try to edit that, and then store it, and then do a lot of mixing and kind of a lot more stuff and all that. So as these times are passing by, this especially the spool has brought in a lot of technology. The way the spools began to, for example, we find that even now when you go to some people, they will say that they'll say it's a spool, analog spool simulation, right? Or a spool saturation, analog saturation, spool simulation, and then that spool delay, right? These are the kind of a spool kind of a chorus, or the reverse of the sound and all that. All this been actually the technology which was being introduced by when the spools have come, they began to work with that. And one of the greatest, very greatest, I mean, the kind of a technology what we use today is a multi-track recording, which means that you can record one application. At the same time, you can record, and then you can also delete, and you can redo multiple things and all that. All these things have happened with the spool. So even today, when you see a DAW means digital audio workstation. So you keep hearing this DAW a lot of the moment you come into this. So this one is basically the DAW helps. Basically, the computer is the one which will help you to get that sound converting, and after the conversion, you will be based on the hello. Okay, so based on the spools and all that, the same spool technology, even today the DAWs are being produced, or many DAWs. Whenever you see a DAW, it is just like that, digital audio workstation. You will find the multiple tracks and all that, just like a spool. So you can go to any track, you can enable or disable, you can record, you can erase, you can re-record, you can I'm trying my best to see that how we go through this. I'm trying to see that if I can connect my computer again. So this DAW is a one which helps us to, nowadays the new DAWs have come, they can take up to multiple number of tracks. Earlier days, the spools used to have about 2-track spool or a 4-track or an 8-track. Maximum, they used to be a 32-track spool and all that. But now we have the DAWs which can goes up to a number of tracks that we find. And another important thing that we find is about, one second, I'm just trying to, yeah, one more important thing that we find in the recent days of these DAWs is, just excuse me for a small little glitch. 1 second, I'm just trying to, just 1 second, just be online, 1 second.
For the benefit of students, I am typing on the chat whatever he is speaking. Can you follow that?
Father, I'm trying to connect to my computer so that we are here.
Yeah. I am in fact speaking to those who are listening to you.
Yes,
I am typing it on the chat section, all that you are saying.
Yes, Father, I can see that.
Okay.
I am
Like,
sorry for this.
Father,
we are follow.
students can also ask some questions. Or
No,
doubts about-
he will just set it up. I think
I'm actually I prepared everything on my computer, but unfortunately it's not getting connected for some reason. Like I think Father also told me that he can see my name, but not able to connect. So just 1 minute. I'll just most probably hoping this will connect. Okay, meanwhile, if anybody has any questions which is related to the studios or the live or what you have anything, just you can ask question, we can see that and then go further. I'm trying my best to get to this. Father, I think I am still trying to connect my system. It looks like
Okay.
there's some problem. Anyway, so so the DOS have come in and then they have made the lives much easier to record and all that. So once we understand the sound is being propagated this way, and then we understand the speed of the sound, we understand the frequency responses and all that, and the human hear what it can hear, to what extent, and then the human hear also having an ability to listen to the sound. I mean, many times there's a confusion about the sound intensity versus the frequency and all that. So intensity means the volume, how loud the volume goes. Is it the loudness? If it increases, is the frequency increasing? Not really, no. It is entirely different. So the loudness of the sound, we can hear up to 130 decibels. Beyond that, your ear starts to bleed. So we have to be a little careful with such kind of things and all that. Now, coming to the point of with the DAW. DAW is the one, before you connect your DAW, we normally have to understand one more small thing. It's called the A to D conversion. So this is nothing but whenever you're talking into a microphone or any device which is sending you an analog signal, we have to see that how this computer can understand, because the computers don't work on an analog basis. They work on digital basis, the zeros and ones and all that. So how these analog sounds, which have been produced from the microphone, which have been coming from the microphone, they are getting converted to zeros and ones. So this happens through a process called the A to D conversion or analog to digital conversion. So this one will be done basically it will take an analog signal and it will divide into multiple parts in the form where we understand them as a multiple blocks, as multiple small bits and all that. So each bit can be a 0 or a 1. The value of the bit can be a 0 or a 1. So that way it will take up and then it will go on to feed into the computer. So the computer reads that, and then once it reads and everything, again when you want to listen back the same thing, then again it has to convert from the D to A. So A to D and D to A. So this will be done by the small little devices or a device we call it as an interface or A to D or D to A converter. Now, here we have to understand one simple thing. Whenever you operate a DAW or whenever you work on the digital system with your computers and everything, there are two parameters it will ask you. One, what is the bit depth? Another one is the frequency, sampling frequency. So these are the two things that you'll find in a DAW before you start your session for your recording. So this DAW, basically now we started with 4-bit, and then in fact the 1-bit, 4-bit, 8-bit. Now people are talking about 16-bit, 24-bit, and so on and so forth. And the frequency they started with earlier from, it used to be 36, then 44.1, 48, and then 86, and then 96, and then 128 and 196K and all that. So we have to see that the more the frequency and the more the bit depth, we get the more the resolution of the audio quality and all that. But all the time, do I have to operate the system with the same higher bit depth and then this thing and all that? Not really. We have to see that the compatibility of your devices. If the systems are your, for example, your interface versus your computer is not really compatible, then there's no point of using this high frequency conversion rates and all that. And in the world now, I wanted to basically make you understand, okay, these kind of things that you can find on the internet, it's very easy to do it. I would like to talk about some of the important things, what really goes wrong with the YouTube and internet, and then the people who have been talking without really understanding. For example, what is the sound quality difference between a 48 kilohertz and then 192 kilohertz? Right? Which one? So by default, we'll say 182 is best. But sometimes when you have seen some of the recordings which are done in the earlier days on 16-bit and then 44.1 kilohertz, it sounds really superior and then fantastic than compared to most of the newer recordings and all that. So why is like that? People had a lot of debates and discussions about it. No, it is not like this, not like that. But I tell you, one of the most important things. Now, I think we are coming to the point of the audio techniques. So other things, what I've been told earlier about some basics of the audio that you can find on the internet, that's absolutely fine. I mean, anybody can teach you. That's nothing really big. But the point of the audio techniques, when you talk about the audio techniques, how do we identify, by what frequency do I go in, or do I choose to work with a DAW? The first and foremost thing is that every student who is working, who wants to get into this line, they have to understand that one thing is very important, that they have to train your ears. You have to train your ear to identify what quality of sound that you're listening. Number one. Number two, once you listen to the sound, the source. Now, this is one of the most important thing. We need to have a reference of the sound in our head. Mostly we get carried away by the trends, what is running in the market, or somebody is telling this and that, so we just carried away by that. But we need to have a reference of that in our head of a sound. For example, if somebody is playing a guitar, we should be able to, okay, this is an electric guitar, or this is an acoustic guitar, or this is a semi-solid guitar. So how do you identify that? Or somebody is playing a drums, okay, this is this sound, this is that sound. And then I know some people, they identify even sounds of the cars and bikes and so on and so forth very accurately. So this is nothing but you will carry a reference in your head. So this is one of the most important thing that you have to always have in your head, the references of the sound what you carry in. And then, for example, you wanted to work in a very high profile audio system and all that, then you need to have a reference of how a really good quality audio system sounds like. So these are the ones which you need to constantly, you need to keep it in your mind when you're working. Another thing is, so here the question is about, do I work with the 48 kilohertz or do I work with the 192 kilohertz? I tell you that many a times the recordings which are done on the 48 kilohertz are far superior than the ones which are done with the 192 kilohertz of your device or your electronics systems, which is not really good. So some of the good systems, definitely, and mostly the good systems are kind of expensive. So these expensive systems, sometimes the good ones, which even though they work on a lower sampling frequency and then the lower bit rate, they produce a very good sound quality and all that. Number one. Number two, so do not simply depend on the specifications, what you find on the computer, to be your guide to a better recording. Do not believe in that. Believe your ears with your reference in your head. Number two, usage of the right microphones. Right, this is one important thing, that whenever we want to capture, we need to use the right microphones for your recording. For example, today I got this microphone here to my house to record some stuff, to basically to speak into it. maybe if father permits, maybe actually today I should have done this through my studio. Maybe the next time, if everything permits, if everything is good, if the Madam also agrees, I will take you through the studio tour of my place, where I will show you that we have about more than 150 microphones with us. So we use these different kind of microphones to capture the different kind of sounds. So the microphones for your vocal application, the microphones for your guitars, the microphones for your drums, the microphones for your string instruments, for your wind instruments, for your percussion instruments. There are many microphones. Microphones which are used in the studios, microphones which are used in the live, with microphones which are used in the field. So there are n number of microphones are there in the market to buy it. So we have to have the grip of these microphones. Of course, this comes with a lot of experience and understanding of what microphone you have to choose. So you have to identify the right microphone for your application. Now, let's look at some scenario, one small little scenario of the students. I'm thinking that, when you wanted to do a small little interview, so what microphone do you carry? What microphone you would like to take it and go? See, this is one, most of the time, I've been working with the students for quite a long time, along with Father Ludraj and all that for the more than 15 years, or I think more than that I've been teaching. So students, they always have this tendency of somebody is telling something, so they just come with that, or they don't get prepared with the right microphone. Let's look at the scenario of a person we are interviewing, we're recording somebody's interview. So what microphones do we carry? So most of the time, what the people do is they use a small lavalier microphone or a lapel microphone, that small little one, tiny one, which they clip it onto your collar or your this thing, and then they talk into that. Most of the time, these ones are omnidirectional. Omnidirectional means they capture the sound from multiple sides, all 360 degrees. So we have to identify the microphone. What is the type of in other words, it's called the polar pattern. So the polar pattern of the microphone is the one which defines from which direction the microphone picks up the sound. So if the microphone which is picking up the sound from all the directions, for example, a microphone like this, which is picking up the sound from all the directions, which is omnidirectional, which means 360 degrees. A microphone which is capturing only sound from one side of this, it's like a heart shape, about 180 degrees, like this. When you cross a plane like this, everybody capturing the sound like that, then it's called a cardioid microphone. And then the moment you go from a cardioid, then you have a supercardioid, which is even more narrower. It becomes to capture the more narrow sound, and then hypercardioid and all that. So we have multiple patterns of the microphones that we see it. So whenever you go to that kind of an application, if it's an ambient noise is too much, your noise around the person where you're interviewing is too much, then you have to see that you are canceling your omnidirectional microphone and then carrying your unidirectional microphone, which points at that one particular guy or who's talking. So that's the reason why when we see some of the interviews on the field and all that, they will carry a microphone which is like a microphone with a shield like this. See, this is called basically a windshield, a small little sponge which is there covering this thing, which will help you to basically to avoid the wind directly hitting the membrane of this. But you will also find the microphones which will completely cover like this, like a fur and all that. It's called basically Rycott fur and all that, Rycott Ricron kind of a material, which will be covering that microphone. It will be avoiding all the noises which are coming from the directions and all. And this one will be trying to focus only to the point where you put it, to the person, whoever you wanted to focus to at that, it will try to capture that. So use that kind of a microphone. So we need to understand, okay, that kind of a microphone is important for us to carry and go. So the right application, the right microphone is one of the most advisable or the most wisest thing that we suggest to do it. And similarly, another thing, what I suggest is, now what else we need to do it? We need to have a good pair of headphones, something like this. Sorry. Yeah. A good pair of headphones like this, maybe over an ear, which covers your over an ear and all that. This will help you to capture some good sound whenever you are trying to do that. And another thing is the students, and especially not only the students, many of the guys nowadays, this has become a trend that everybody wants to use the in-ears and all that, the small in-ear plugs and all that, which are good to an extent to listen to a very short while, or easy to carry, put in your pocket, and then is very, very minimalistic. So you can just put in your pocket and then can go. But these are harmful. If you're using them for a long time, or with the loud noises and all that, it is really, really harmful. It is going to make you deaf very, very, very soon. So avoid such kind of things. Maybe use the headphones like this, ones with an over your ear. So you can put them on your ear like this, and listen to the sound. And then whenever you are exposed to the loud sounds and all that, try to take a break. This is really, really helpful. You try to take a break so that the whole structure of your ear, it will reset, and then you will be able to have the good listening and all that. So in this scenario of an interview, carry the right microphone. If the ambient noise is too much, then you have to have a microphone which is pointing toward that. The polar pattern is like a superchordioid or a hyperchordioid, at least a chordioid pattern and all that. And then take it and then put it towards the people, and then record that. And then while you're recording, use a good headphones to see that if there are any noises which are coming in, so that you can avoid that. And one of the scenarios where I have met, where one of the good tool which will help for the recording is an umbrella. People ask, why umbrella? This is an excellent audio technique. Umbrellas help you. Number one, it will protect you from the sun and the rain. Umbrellas help your gear to, it can protect your gear. The most important thing, you might say that, I'm working in a shade, I don't really think, I'm going for an outdoor, but umbrellas can help you from blocking the sound or the wind which is hitting your microphones and all that. This is one excellent tool, which is really like one what do you call the Bond's tool, like one James Bond kind of a tool. It will help you from the sounds and the noises which are coming from the directions, so you can really avoid that getting into it. And one more important thing is that the sound is the least controllable of all the 5 sense modalities. We have 5 sense modalities. So among the 5, this is the least controllable. So we need to take, it is better to take a lot of precaution in the sound recording than to struggle with it later and all that. And then there are many cases in the audio. We have multiple options in the audio. We have multiple options to make around, to create a lot of gimmicks and all that. But in the sound, it is very, 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 very complex. You can't really do that. So you have to keep that in mind all the time whenever you try to capture the sound. Another one. Now coming to another issue is like, how do we record? What do I record? I mean, when I carried a microphone, I'm using it for a person, and what do I have to see it? What do I have to look at it? So before you hit the record button, you have to see the levels at what you are capturing. So what is the level that you are capturing into your system? So this level mostly we consider to be a 0 dB. So dB is nothing but the unit for the sound, especially, so that you have to see that what is the dB, how many dBs I'm getting into the system. So mostly you have to see that it's a logarithmic equation. So you have to see that it reaches 0 dB. That's an optimum level where you need to capture the sound. So whenever you're capturing, see that the microphones or any input that you're playing through it, when it is coming to your system to record, you have to see that the levels are recorded at 0 dB. So beyond 0 dB, when it crosses the 0 dB, you will end up into a section called the distortion or a clip zone, or the lack of a headroom and all that. So that when you enter there, you will end up in disturbance, in a lot of distortion in the sound. So you have to avoid that. You have to see that it has to be at the 0 dB. What happens if at all you record less than 0 dB? I'm recording at, let's say, about minus 20 dB, minus 30 dB, minus 40 dB. It is very nice. No distortion is happening. I'm not going to distort my sound and all that. So I'm absolutely quite good and all that. But the problem is, when you record something that, whenever it comes to the point of a broadcasting or showing it to somebody somewhere and all that, then the point is about you have to increase your level. The moment you are increasing your level along with the voice or any input and all that, it also increases your ambient sound. So it's again useless. There are certain devices called the gates, noise gates and all that. We can use them, but it is very artificial. You can't really use them very efficiently, and they don't really sound nice, very good and all that. So it is very important to choose the right microphone. at the right application, use some tools to avoid the sun, the wind and all that, by an umbrella or like the Rycott fur or like a windshields, and pop filters and all that, and record the sound at 0 dB. Use your headphones as you're recording, use the headphones properly, and then you record that into 0 dB, and then bring it to your studio or your place where you can do your post production and all that. And now coming to another issue, like what we find, how do I understand other things? One of the most important thing, sound is like a it's like a big chain. I mean, it starts from the source and then it ends with your speaker or the listening venue. I mean, to be very precise. So it starts with the person who's playing, to singing or who's talking, and then it ends with the person who's listening on the other end in a venue. So this is a big chain of multiple links. So in this multiple links, even if you have a small glitch, let's say a small little connector issue, for example, something like this, a small connector. If this connector is bad, right? If this kind of a connector is bad, the whole recording is bad. Even this cable is bad, right? You can see this cable, we put some kind of a shielding here so that it will not bend too much and it will again come back to retrieve to its position so that the cable doesn't get spoiled. So every smallest detail that we have to really look into it. So every weakest link in the chain, if that link becomes more weak, you're going to lose the connection. So you are, and then especially the audio distortion, which is really annoying, and then we'll not be able to really restore them back and all that. So every link in your chain, in your production, is very important. So right from your microphones, now let me also talk a little about the placement of a microphone. Many times people say, what is the best method, or where do I have to keep the microphone the best? I'd say that, I mean, somebody says that it is already, it's a good point. They said, wherever the instrument is sounding the best, you put that there, which is 100% true. For example, if I am talking, this microphone is, let's say, it's an omnidirectional microphone, or it's a unidirectional microphone. This is capturing the sound from this side, and then I keep the microphone like this and I'm talking. It doesn't really make sense. It's a good microphone, good cable, good interface, everything is good. I'm trying to record, everything is good. But if my direction towards the person is not good, then you are lost. Similarly, what distance do I have to keep from the mouth of a person or from an instrument? Mostly when you're coming closer to the microphone like this is also called the proximity effect. When you come closer, you will have more lower end, or the bass will be more and all that. As you go out and all that, you lose that low frequency response and all that. So you have to have a balance of both. Not really too much of a bass, not really too much of a treble. So you need to have a balance of both. Most probably from 3 inches to 6 inches is the gap that you have to maintain whenever using a microphones like this. Of course, I have seen, I mean, since we are talking about the audio technique and all that, people say that, Trump is talking into microphones which are somewhere on the desk. Yes, those are the microphones which are there somewhere on the desk. So I also would like to keep a microphone like that and then talk onto it. Does it work? If you have that microphone, yes, it works. If you don't have that microphone, it doesn't work, because those kind of microphones are existing. They work on a principle called the hypercardioid, very narrow beam. They don't capture any sound coming from any directions, only one particular direction. To be very precise, I think it's about 110 degree of your dispersion. It will capture the sound on that direction, and then it will be capturing that kind of a sound very clearly, very precisely from that particular spot. So when you want to buy a microphone like that, yes, it does that kind of a job. Number one. Number two is after doing the microphones recording something like that. So one is that, and the second thing is that in this audio chain, it is not only that, but every element. For example, if your audio device, the interface, it has the conversion rate is bad, or your preamplifiers are bad, right? We have to see that these things are supposed to be really good to record that good quality sound. And coming to the post production and all that, now one more important thing is that how do I understand? Okay, I'm carrying a condenser microphone. So what do I understand? So mostly see that this is one simple technique I'll tell you. This really I mean, I have learned from some of the old engineers this way, and then I would like to pass on some kind of a technique. Nowadays, people have lots of softwares and then lots of measurement tools. People carry the small kind of microphone, small kind of a device in their laptop. The engineers, they'll come, they'll run some pink noise. Pink noise is nothing but it's a band of frequencies from 20 hertz to 20 kilohertz, which generates at the same time with all the frequencies of the same intensity. We can find the pink noise on the net. So they run the pink noise through it, and then they run into the system, and then they'll see that they use this microphone to calibrate. What was the old time? What the old time before the pink noise? What the people were doing? They were using their ears to listen to that. So they listen to the sound from the ears, and then they do it. So one of the best method to understand, the sound, the way it works, is very, very, very simple. The quality of sound, whenever it comes to it, if the microphone that you're carrying, if it's sounding like you, right? This is a super excellent technique of identifying this quality of the microphone or the quality of the total production itself. If you are sounding like you, then it's a good thing to go ahead. If it is not sounding like you, if it is not, it's not exactly that, it is slightly different, a little variant here and there, then I say that, you are somewhere, some part of your link is wrong. Maybe the microphone, maybe your interface, maybe A to D, D to A conversion, or maybe your amplification, or maybe your speaker, or maybe the placement where you kept the microphone, or the placement where you kept your speakers to listen and all that. There is some problem and all that. So we need to identify these kind of things. And one more issue would like to bring it up is called the acoustics. I mean, where do I listen to? For example, I captured a good sound. I took a good interview. I put the person in a nice room, and then I use the right microphones and all that. And then I began to get a good conversion rate. And then I used a good sampling frequency and everything. My preamplifiers are really good. I took a 0 dB into consideration. I recorded everything correctly. And then when I played back, now here comes another set of the issues. What we find on the audio is about your speaker system. So normally we find the speaker system with many of them are really, they don't really care about the speaker system. Of course, sometimes I see the people, they care about the microphone. For example, I mean, I'm really sorry, I'm not able to show you that, but you can just go and see on the net. The moment you see a microphone, they say a microphone, you will find one microphone brand which is called the Shure SM58, which is a worldwide popular microphone. I think they would have made some millions of microphones like that. It is present in every country, I'll tell you. I think in every state, every city, you'll find that microphone in the world. And this is a very popular microphone, very economical. So people tend to follow that. Okay, this is a microphone which I can use it everywhere, whatever I want to do. Of course, there are some fellows who does it very trickily and all that. For them, it is absolutely fine. But for you to understand that microphone using an SM58 or SM57 or any other microphone, we need to understand the other side of it. That is what is your speaker system. So basically, the speaker is another one device, which is again a transducer, which works opposite direction to the microphones and all that. So whenever the sound is coming, you will hear that sound, and then the amplifier will amplify that, and then it will produce the sound into the speaker. So the speaker vibrates and then reproduces a similar kind of sound what the microphones are capturing. Now the speakers are about, again, there are 3-4 different types of speakers. The speakers are being designed to 2-3 different types, because the one speaker is not able to vibrate or generate the same kind of a frequency response into similar kind of a response. We are not able to get it. So they have produced some frequency responses, understood that, okay, the one speaker can't really produce all the 20 hertz to 20 kilohertz. And we will 20 kilohertz to 20 hertz, and then we will be able to listen to it. But just imagine one speaker which is vibrating at 20 times per second. The same speaker has to vibrate at 20,000 times per second. Impossible to do that, right? For that, to understand that, very simple. You can take one rope, a big rope, one thick, nice big rope, take it about some 10 meters length and all that. Try to vibrate like this. Maybe you can find this in the gyms also. They'll use ropes to do an exercise. So use that rope. Try to create big waves. At the same time, try to make small waves. You see what will happen to the rope. The rope will not be able to produce the big wave and the small wave simultaneously. Either it will produce small waves or it will produce big waves. So that's the problem. That is the problem. That's the reason why we have to be very clear about the speakers are not able to produce that kind of a sound. So they have divided the speakers to some they made it to work on a small frequencies, some they made it to work on a bigger frequencies. So the one which works on your low frequencies, the bigger frequencies, we call it as an woofer. The small ones which works on a small high frequencies, but we call it as a tweeter. So right. So now another one which has come up in the middle, which are not able to produce the higher and the lower. Some of the middles are not been missing. So that one is called basically a squawker or a mid-range speaker. So they have about three different kinds, basically three different types. There are super tweeters, there are subwoofers and all that. That's a different story. But for an oral application for a person who is talking, we want to listen to them, that kind of a music application. Yes, it is the three types of speakers: woofer, a squawker or a mid-range, and a tweeter. Of course, we also have the subwoofers. Subwoofers take below the 30 hertz, 40 hertz and all that. They'll go up to even 10 hertz or something like that. They'll vibrate and then kind of give you kind of a feeling. So this is how this frequencies and the speakers work. Now the point is, I have recorded everything correctly and I have brought it into my system correctly, and then I have put everything correctly. But when I put it onto the speaker, it is not really giving that kind of a sound. I'm not sounding like me. So there we need to address that, look into a good a speaker system that we need to look for. Now, this is one big challenge. These two are the biggest challenges we find in audio. Most of the other things like your audio system, like your DAWs, your mixing consoles and your workstations, the way you work, everywhere you can follow somebody. You can follow the trend. You can follow the people who are talking about it. But the most important thing is that your microphone and your speaker. This is the most trickiest thing, where the 99% of the people fail is your choice of the microphones and the speaker, what you're listening to. Now, for example, because of the tools what we have right now, we can really make a lot of kind of an editing on the DAWs, and then create a lot of, we can add, we can delete, we can control the audio the way we want it. But whatever we are doing, we need to really listen to them in the right manner. So many times people use the software to analyze these kind of stuff. I say that the softwares really don't help you, don't really work very well. They have issues like, the spectrum analyzer is not really that great to see. So by looking at the software, by analyzing an analyzer and all that, we'll not be able to gauge the quality of the sound. So we need a good quality speaker to listen to the sound, whatever we have been recording or whatever we're producing. So that's the reason why whenever we work in the studios, we see that it is called the reference monitors, right? So this reference monitors, again, olden days, they used to have nice, good ones and all that. Of course, now also we have good ones, but very expensive. The good ones, the good reference monitors, which I suggest something, is very expensive. So we have to be really careful about the way these monitors work. Another thing is, like, now we come to the point of the acoustics. Okay, before we go ahead with an acoustics, if you have any doubts so far, or you would like to ask a question, something related to the audio, something like that, you can raise your question. Ma'am? Reference monitors are very important, yeah. Hello? Does anybody has any question?
Yeah, anybody has any questions, you can ask.
See, we are going in a yes, go ahead.
You can put it in the chat box, or you can unmute yourself and you can talk, you can ask. Those who want to ask questions, you can unmute yourself and ask.
You can either type or you can ask the question. You can unmute yourself.
Hello.
Yes, you ask.
Yes.
Sir, I am a media student, and as a media student, I have gone through all this, and like a big doubt that I have is what kind of microphone, these days there are a lot of Rode microphones, right? The Video Pro and all that. So which one should I like invest in? Like a boom one or like something like that video microphones, like affordable ones?
Okay, it's a good question. See, what is this boom microphone? Let's look into the boom microphones and all that. Now, how do I identify what's the microphone do I have to use for an application? Now, this depends on the application, right? For example, I'll tell you, when we see a reporter, he will carry a long, it's called a shotgun, right? You'll have a long microphone and then with a windshield on top of it, right? So this is called a shotgun microphone. So what the shotgun does, it captures the sound even from about 2 feet distance. So why they use this microphone? The simple reason is the microphones, whatever, for example, I'm using this, if I, until unless I keep it close like this, I will not be able to, you'll not be able to really get a good sound of it, including my proximity and then the noise and everything together. But if you keep like this, it is covering half of my face. So the video journalists, what they do is they want to avoid that microphone, the face covering microphone. So they use a microphone which is called a shotgun. So the longer, one easy technique to identify is the longer the gun, the longer the shotgun, right? It is tend to capture or focus the more towards the guy. Very simple. The shotguns, of course, there are some shotguns, don't get confused with this. There are some shotguns from a company called the DPA. Very expensive, that much it will be. It will be hardly about 2-inch. But the way it focuses towards the person is incredible. I mean, there's a different engineering, very good engineering. It's from Denmark and all that. Superb microphones and all that. But on an easy to understand simple application is the longer the shotgun, it is trying to focus towards that. For your video application, if you want to mount it on your camera, yes, Rode is a very good company, which is from Australia. They make nice mounts for the cameras, but do it. But the microphone, the problem with the Rode is, if you want to capture that person, if your camera is away, let's say about you're 14 feet away, 15 feet away, 10 feet away from the person, and then you are in a venue, there's a kind of an ambient noise, right? People are talking everywhere. This small little shotgun on your Rode, which is mounted on a camera, will not really help. You have to look for a shotgun. I mean, the focused, very like a hypercardioid shotgun, right? So you have to have a long microphone which has to be mounted. So you see your application, what you are looking for. Are you going to work with the people who are working with a very close proximity, or you would like to shoot from a distance, just capture some ambient noise, and then you are okay with that, or you're inclined towards the quality of sound? Another solution I'll also give you for this. One is one super solution. For example, when you go with a good team to work, you carry your camera and then you carry a small little device. This you can look out for on the internet. This is called Sound Devices. There's a brand called Sound Devices. They make excellent, superb products. Guys who are interested to get into this line, keep certain microphones, certain cameras as your personal, you would like to use it in the future. I suggest do not buy something cheap. Do not buy something cheap. Buy something really good, and then it may not be expensive sometimes, but you have to see a good quality one. Buy that. So what they do is they use a microphone. It's called a fishbowl. Fishbowl, so the kind of a microphone stand, which you can connect the microphone to it, and then it will be from above the person, above the frame of your camera, and it will be pointing towards that guy. So your microphone is here. You are about 10 feet away from that. But the microphone which you're pointing towards a person is hardly about 3 feet away from him. So use a technique like that, like a fishbowl, boom microphone and all that. Use that and capture that sound through a small little audio interface or any other sound devices kind of a device, or your Tascam or Zoom, something like that, and then get it into your camera. See the application, what you're looking for. Rodes are good. I don't say the Rode is a bad company. It's a good company. You can invest in that. I hope it's clear.
Yes, sir. Yes, sir.
Yeah. And any other? So you students already have started this course, or you just going to start?
So we have started this course.
You started already. Okay. And one more thing is that Shure makes some good shotgun microphones. Sennheiser makes some good shotgun microphones. Okay, going to start. And the brand called the DPA makes some very good microphones. DPA is very expensive and small in the structure and all that, but excellent to work with. You can see those. So whenever you guys who are interested in this line, there are plenty of tons of microphones that we can buy it, and then we can use them. So you have to just go a little, do a little research, and then you'll be able to understand. And one of the best method I'll tell you is to identify these microphones or any of the device, do some practical work. Take the microphones, whatever you have, just take them on the road, take them to the venues, try and then record them. And then once you get that microphone, the quality and all that, compare it with some of the good quality recordings, similar kind of a recordings of somebody's doing it. Then once you capture that, then you compare it with both, and you see where you're missing on your audio. And eventually 99% of the application, it goes that, people who have fantastic recording, they have fantastic tools with them. So it is by default, it goes that, if you have very good recordings and all, microphone recordings and all that, eventually they use a very good tools, right from the microphones, good cables they use, good connectors they use, good interface they use, and then the good techniques they use. And one more thing is that, for example, you are in a venue where there's a wind which is coming from one direction. So you choose that, the microphones are being kept. Don't keep the microphone against the wind, but keep on the back of the microphone, hitting the microphone wind and all that, so that you will not really get that sound into it. So be a little wise when you are trying to use the microphones and all that. And similarly, a good headset is one more most important. This is one challenging thing for most of the engineers right around the world, I can tell you, is the low frequency control. How do you control that low frequency response in your mix when you're trying to get that? How do you understand that the lowest boom and all that is very, very, very challenging. So I suggest you have to invest. This is one, you might not really invest in a good microphones because when you go it, but I suggest every audio guy who is interested in this audio line, invest in a very good professional headphones. Good ones might cost you somewhere around 15 to 20,000 bucks. One of the good ones are from the Biodynamic. There's a model called the DT770, which can be used for the recording, mastering, mixing, outdoor, indoor, everywhere. It's a rugged microphone. That is one from Biodynamic DT770 Pro. Another one is from the Audio-Technica. It is called ATX50. So these are some things you have to buy it and then keep it with you, because they'll last really, really long. And then it'll create a reference in your head. Okay, when I listen through this, I trust my headphones. When I listen through this, okay, the treble is not bad, the bass is bad, the mids are not clear. So you'll over a time of listening, you will get that. You will come to understanding of these are the microphones which really does a fantastic job like this. So I can trust my headphones. So basing on your headphones, you can pick and choose. Okay, you can identify, okay, the microphone with what the guy was using is bad, or the editing was bad, or the guy who's the interface is bad, or the cables are bad. All these kind of things you will understand by the reference of your good headphones. So I suggest and rather encourage everybody to invest in a very good headphones for your application and all that. Yes.
Sir, I have one more doubt. Like, I have used the Zoom H4n once, and it was a bit complicated for me. Like, I was recording a sing sound short film, so it was quite flat, and there was pretty good noise from the around. So I just have a doubt. Like, how do you record through this stereo setup with less noise as possible and best quality but low data? Like, the MB of the file should be a bit less, but I should be able to manipulate the sound as well in a pretty good way. So do you have any settings for that?
Now, one simple thing is that, right, this
Hudson,
Father.
1 minute. I think you must also explain to them the importance of dubbing sound.
I'll go there.
Okay.
I'll do it, Father. I'll do it.
Yeah.
Thank you, Father. So here, what we are looking at is Zoom. Zoom is a basic kind of an entry level kind of a devices that you find in the market. This is one of the biggest issue that we find with most of the manufacturers in the market. What these guys they do is they give you specifications for it. For example, a microphone which is like this, they say this is an omnidirectional.
Sir, we can't able to hear your voice, sir.
Or they say it is a chordioid pattern. Chordioid pattern means it has to be 100 microphone really doesn't do the job. It will. Hello, can you hear me?
Sir, little bit distance.
Okay, so we have to identify, basically we have to be very specific with the microphone specifications and all that. For example, Zoom, it says stereo application and all that, which means that it has to give you, there is a difference between the omnidirectional and the stereo, right? When you're using a stereo, which means that it is supposed to capture the sound, which is about in 180 degrees, you are supposed to get that. But in a omnidirectional, if the microphones are not really good quality microphones, it will try to capture the sound from the other directions also. So when you're using a Zoom, I presume that you're using a Zoom in a very ambient noise place, which means that the microphones which comes with the Zoom recorder are not really good. I haven't seen any of the Zoom recorder having a very good microphones like that. In fact, for that case, I haven't seen any of the device which has come with an inbuilt microphones have a good quality. Everybody, I mean, all the professional guys I've seen, they use an external device, an external microphone to record that. So far, I've seen a lot of Sonys, a lot of Zooms, a lot of Rolands, and a lot of Tascam I've seen. So all these things come with a small little microphone which are built onto it. But I prefer that you use another external microphone, which is having a proper sound shielding like this, a record shield or something like that, windshield, something like that, and then the direction of where you're using that really helps. So avoid using the Zoom. I really don't prefer the Zoom to be used on a very professional manner. Zoom is a good recorder, but use an external microphone.
I don't know.
I prefer that, using an external. Yeah. And one more thing is that, for example, as father suggested, for example, you have gone to do a shooting. For example, you are doing a small little shoot of film.
Hello.
Yeah, we can't hear you, sir.
Yeah, actually, yes. Left, I think so.
I think it got disconnected.
He has got disconnected, ma'am. Yeah, he has got disconnected. Maybe you can ask Rudra sir to take it.
You are connecting, okay. Madam is connecting, he's connecting.
Connecting, okay.
Yeah,
Okay.
just hold on. He's connecting.
Okay.
Yeah.
Jerin,
Yes, sir.
you can just put the feedback form, man. Few people are leaving out.
Okay, sir.
Yeah.
Maliha, ma'am.
Yes.
Hello. Father.
He's joined
Hello.
back.
Yes, sir.
Yeah. Sorry.
Yes.
Connection.
Yes.
Okay.
So what I suggest is, whenever you go for a shooting, you go prepared. For example, you have certain script to the person and all that. You go prepared, and then use a clap. Clap is one excellent device to use when, especially for your recording. Use that clap, what we see in the movies and all that. Use that kind of a technique, and then use a clap. Ask the artist to say whatever you have to say it in the script. And then once you finish the recording and come back, that reference, whatever you have recorded on that site, on that venue, keep that as a reference, and then you can redo the voices and all that. That's what we call it as a dubbing. So use this dubbing technique. Most of the things what you find on the making of a films and all that, they use 99% they use dubbing. So they don't really capture the good quality sound. It is sometimes, even if you have a very good microphone, very sensitive, directional, somebody comes in and then kind of somebody honks, some fellow runs in a car or something, kind of a noises and all that. So avoid that. The best thing is that keep that as a reference. Record that. Don't avoid recording. Record that. Use a clap so that the clap really helps you to sync your audio and video together, and then put that into this perspective, and then get the whole thing together in the post production in your studio, or when you're doing it later. Use a voice to record on that. Using that same script and all that, you can record that so that you'll be able to sync it very well with the clap and everything and all that. So this is one method, good method of, it's called the dubbing. So use this kind of a techniques for a very good audio production and all that. And so if at all we finish, okay, I think there are many questions you can ask about what happens to for example, the field, especially the people who are interested. One of my cousins, she is a sports journalist in US. So she's also studied her mass communication, and then she's a sports journalist in US. So they use a different, especially on a field. We find this, especially on a cricket field and all that. On the cricket field, you will about 10, 12 microphones on the boundary and all that. The small microphone with like a small little Pomeranian dog. So that's called the Rycote fur, the Rycote windshield. So there'll be a microphone into it pointing towards the cricketers, or the pointing towards the players, what they're doing. So that is a field microphone. Mostly it will be a cardioid microphone, or sometimes they use a omnidirectional microphone. All the microphones get into a post-production setup, what they do it, and then they work from there. And there are microphones nowadays, people are keeping it in your bat, the cricket bat. You'll find a small little microphone, very small, so that especially when the ball hits the bat, to understand that you can see it on the screens also. And then there'll be microphones on your small little microphones on your wickets also. You'll find the microphones. So like that, there are multiple kind of scenarios that you'll find that people use the microphones. So all this can be used for different applications. And then also find the parabolic microphones. This is one of the old techniques. Nowadays, people are not really using it much, but it really helps to capture the sound which is coming from a very far distance. For example, you are on this side of the stadium, and then somebody is making that side of the stadium making some noise. So you'll find a big dish. It's called a parabolic kind of a dish, which is about semicircular, and then the microphone will be facing into it. So the sound comes from that direction and then hits the dish, and then it converges the sound and then enters the microphone, which is facing towards the dish. Just like your LNB, your dish antenna, or what you find for your TV, similar like that. But there'll be a microphone connected to that, and then it will connect and it will go. And then there are some microphone which is called the PZMs, pressure zone microphones. It looks like when you see that, it looks like your small little mouse, right? But the only thing is that the mouse will be like this, so there'll be another zone or another membrane like this, a big membrane like this, like a phone. So you'll find that the small device on that, the area. So for example, instead of this microphone which is having a small diaphragm, which is hardly about a centimeter or something like that, a small one. Now the small little centimeter diaphragm, what they try to do is they try to use a bigger diaphragm, about a 2-inch diaphragm, and then 2-inch diaphragm is induced by another surface which is about 4 inches, 5 inches, 6 inches, even 12 inches of a surface. So that's called the pressure zone microphones and all that. So they're basing on the application, the vibrations of which are coming from all the directions. That plate will vibrate, that will send the signals to this membrane, and then through this membrane you can capture the sound. Like that, there are many microphones we use. And then one of the most important thing is we find the microphones for especially for drums. Drums is one very critical application where the microphone, the way the drum sounds, the way we've been hearing the drums are very tricky. I mean, the drum, the way it sounds, at the moment you put the microphone there, it sounds kind of a different. So we find it very complex in a way. So that's another different area to where you have to get your expertise after working with the microphones and all that. So the microphones, that is number one, and the microphones which have been used. In fact, we've been developing a section. We have done a very good R&D development section for the Hyundai in Hyderabad, where how the audio of the car can be fine-tuned by using the measurement microphones. So this is another microphones which you can find it on the internet. This is the brand called the Earthworks, and then B&K. So these are the brands and all that which are used exclusively for measurement. Of course, there are measurement microphones which are from the Biodynamic, where they are from the Rational Acoustics, they are from the DBX and companies brand like that. So these are the microphones which the people use to measure the sound which is coming from the venues and all that, of the how the venues are sounding, what's the sound responses over there, how do you really get to that? Not just instrument microphones, or not just pointing towards a person for a speech, for an instrument, for a guitar, but to measure the overall response of the venue. So especially when they do an auditoriums, build auditoriums, studios and all that, they use this measurement microphone for this kind of an application. So of course, there are tons of microphones. As you get into it, you have to choose the right microphone for the right application. And by thumb rule, one simple thing is that don't invest in a small, cheap devices, because they break, they don't really calibrate, they're not really calibrated well. The specifications, what you find on the things, they don't really match to that. So be very careful. Nowadays, the big brands also cheating us. So be very careful with when you invest in a good microphones or something like that. And a good pair of headphones, which you have to have it. I seriously recommend this to every student to have on professional headphones, especially because whatever you have, you'll be listening to something other. So that should become your reference for it. So I say now, if at all you have any questions here, we will look into those questions. If not, I would like to go into another subject, which is called the acoustics. How does this acoustics play the role? For example, my microphone, I checked at my home. It is sounding fantastic. I did a small rehearsal at home with my friend. We are doing a small shoot. It is sounding fantastic. But the moment I went into that arena, that venue and all that, it started sounding bad. So why does it do that? Why does the microphones behave that way? So those kind of things we will address in the next few minutes and all that. So if you have any questions so far, you can ask, and then from there we can get into another section called acoustics.
Sir, can you please suggest some good headphones, good professional headphones?
Something which is economical and then good ones, I can suggest. One is a Beyerdynamic DT770 Pro, which is around 14,000-15,000 rupees. What I am talking about in the same range. Don't buy an expensive fancy ones, which are some 2 lakhs, 3 lakhs and all that. Don't buy them. They are useless. They're not for us, for the production guys and all that. Something which has to be really good. So DT770 Pro from Beyerdynamic, and then from Audio Technica, it is AT50X. It's another good one. And then from Sony, that you have something called MD540 or something, 5407 or something like that. So these are very popular, very good brand, good sounding, and then very reliable, and then they really they last really long. I've been using headphones. I mean, one of my headphones, I've been using it for the past almost 15 years so far, and then they never broke and all that. Really good ones. So I prefer, personally, my choices are Beyerdynamic and Audio Technica for the production like this, rugged, and they really have a good response, frequency response. And one more thing is, when you buy headphones, one simple thing, most of the people say, there are several reviews on the internet that I see. A lot of people, they talk a lot of reviews, but the one thing which most of them, they forget to tell you is what's the ohms or impedance of the headphones and all that. I'm having a headphones which is DT240 Pro. This is from Beyerdynamic. This is DT240 Pro. I also have a DT770 Pro. So DT240 Pro and all that. So you'll find something called 60 ohms or 280 ohms or 800 ohms. So you have to see that the smaller the impedance, that the ohms is nothing but it's a unit for the impedance. Impedance is nothing but the overall resistance of the device. So the smaller the impedance, it will sound more louder, and the higher the impedance, it can take more load. So you have to understand. Several times when we suggest a DT770, people went and then bought 250 ohms. They said, sir, it is not, my headphones is not, when I connect it to my phone, it is not really sounding very well. It is not giving that kind of a bass punch or something like that. It's not very bright. The reason why is you have to buy a lower impedance, 80 ohms or something, 60 ohms or some 100 ohms kind of an impedance that you have to buy on your DT770 Pro or any other headphones that when you look it for. The lower the impedance, it will be brighter, but it will be delicate. But the higher the impedance, yes, it can take up the load. It can take up, even if you put a very headphone powerful amplifier, it can take up the load. But most of the cases, you don't find a powerful amplifiers. So I suggest a lower impedance headphones for your application. And anything else? I prefer that, I'm really feeling bad about this system not getting connected for some reason. I don't really know. I've tried many times. Maybe I prefer, I ask father and then madam, if at all they permit me, I'll like to do this from my studio. Actually, studio today is not possible to do it. So I would do it from the studio, and then I will show you the reference monitor, the types of reference monitor, the kind of interfaces what we use, the kind of microphones what we use, and the studio acoustics, how they play a vital role, and the isolation, the absorption, and so on and so forth. We can really look into all those things and all that. Any questions so far?
Yeah, I think we can try to do one more with the studio tour, where we can have the microphones, then the DAW, how it works. Also,
Yes.
people can see. Maybe we can try something different
Yes,
next time.
Yeah,
Yeah,
but
can
it
you?
was also very informative, and I think most of the students, they gained a lot. And of course, whenever you have the time, we can have another session next time.
Yes, ma'am. I prefer actually for example, there are many techniques of using the microphones in a studio or something like that. One important thing is that try to see the microphone, try to adjust the microphone for your, one beautiful thing I tell you is, I learned it from a very good engineer. I asked him, where do you place the microphone for a better sounding response, what you get? So one of the beautiful thing what he told is, put your ear to the instrument. You see where you are getting the best sound of that instrument. Use your ear first. So he says that use your ear on a guitar. So see that where it sounds really good. What sound you wanted to capture, what sound you wanted to like. Basically, you are liking that. Put your ear there to see from the guitar, from the body till the neck and all that. See the total fretboard and everything, where it sounds really good. There, put your microphone. This is one easiest, simple method without breaking our head. Of course, on the internet, people talk a lot about issues. Put 3 degrees here, 20 degrees there, 3 inches from here, 6 inches from there. Use this, use that. All they talk about. Maybe good. I'm not saying no. But for your reference, I say that use your ear to the instrument. Wherever this instrument sounds the best, use it there. And one more thing. Whenever you're using many microphones, now this is one very tricky and very important application. For example, can I use 2 microphones for a person who is talking? I can use, but one simple thing you have to remember. The microphones from the source, if I'm using 100 microphones, 100 microphones should be on the same distance from the source. You can use 100, no problem. But 100 microphones should be from the same distance. If the distance differ, then what you call it, it's called the phase issues. It will create some phase issues. Phase issues are basically, it happens with the distance. The reason why the distance means it is nothing but it relates to the time. The time it is traveling, and then it is capturing, the microphone is capturing that particular sound. So that creates a wave problem, and then you will lose on a good quality sound. So you can use 2-3 microphones. For example, I've seen people using 2-3 cameras when they should go for a shoot, and then every camera has a microphone built onto that, and then they would like to use the audio of every microphone into the production, which is absolutely wrong. I mean, don't use all the microphones at the same time. Use whichever the best you can find. That time, that microphone, you try to use that. This is one super technique that you have to use it. And then so the another thing is that people, whenever you try to record the drums or something like that, again, the same application, same principle follows it. You have to have the similar kind of a time. So all the microphones should be at the same equidistance, mostly the equidistance from the instrument that you use it. Of course, there are several challenges that we find, but this is one thing important, you have to do it. And people have another important thing is that whenever you use an application where you wanted to use your microphones, try to see that the microphones produce a natural sound. How the instrument is sounding, your microphone has to sound that way. So try to see that the microphones have a natural sound when you're listening to it, right? So if the microphone is not doing the job, it is not natural, then which means that your microphone could be wrong, or the placement of the microphone is wrong. That is one important thing. See, but the reason why I say this, the natural, if at all we record it very naturally, you will find in the post production it becomes very, very useful to do it, because there is something called when you record, when you try to mix this thing, there is a certain terminology called cutting through, which means that they said, okay, his voice has to cut through, the guitars has to cut through, the bass has to cut through. They say it. Why it has to cut through? When you listen to the instrument naturally, is it not cutting through? It is cutting through. When you're listening to a band performing, a rehearsal is going on, can't you are not able to listen to them, you will be able to listen to them. But why not in the recording? Which means that the application of your microphones are somewhere wrong. You have used a wrong microphone for a wrong application. So those are the kind of things that we have to look into it. So I think if at all you have more questions, you can ask. If not, we will go to some of the issues about what we find about the acoustics, especially in the places where we work, and then what the places where we go. Any questions on the microphones or on the DAWs? Of course, DAW is a very simple thing. You can find many things on it. It's easy to record, easy to manipulate, easy to work. Many DAWs, one beating other, and a lot of effects on that. You can learn them. Maybe in the next time when we go to the studio tour, I will show you how the DAW works and everything.
One thing, I think acoustics could be part of that studio tour, because that will explain, because now it theoretically explaining them and then showing what are the materials we use in the studio, those fabrics, all that. I think that will be a better option compared to this. What do you say, Madam Malika?
Yeah, yes, sir. Any more? Maybe briefly you could tell us.
Okay.
Then,
Okay. Yeah, just briefly tell them what acoustics.
Okay. So when we, as I given you an example, my microphone is sounding really good in the room where I practiced in my home. The moment I take it outdoors or into a venue where it is good. I mean, the microphone is sounding good, but the ambience noise is creating a trouble, or there's no sound which is coming from outside to inside, but there's a lot of reflections in the venue, or in other words, we call it as a reverberation, lot of reverberation that we find. Or some people call it as an easy term is, they say it as an echo. Lot of echo happens in it, delay echo happens in it. So what is this delay echo reverberation kind of terms, what they use and what is it actually? So when you look into this, the one, for example, when you go, we enter into a subject called an acoustics. Acoustics is nothing but, this is a study of the behavior of a sound in a venue. Basically, this word has been derived from the study of sound underwater, but now we have taken it out from the water and then we began to apply that outside the water. So the behavior of a sound in a venue, that is a study. The study what you do about that, the behavior of a sound in a venue, is called acoustics. So in acoustics, there are two issues that we'll find. One is the reverberation, another one is an isolation, right? So two things that you'll find. For example, this is a practical application. So when you go to a venue and then you will find, you wanted to record something, so you'll find the first one is the noise creeping from every possible direction. So which means that acoustically that place is not really viable for you to work there. The second thing is the reflections. Once you close the doors and everything, you shut down everything, all closed, but you are finding the room too much of a reverberation in the room, right? So this is another issue that we will constantly we will encounter. So for this, we have to understand what is the first one. Let's look into the reverberation. What is reverberation? Reverberation is nothing but when the sound is emitted from a source, from maybe a instrument, a person talking, or from a speaker, it emits and then it goes in all directions and then hits the surfaces of the walls of everything and then comes back to you without a time interval. Now this we have to understand very, very clearly. The sound reflects from the source. It goes from the source and reflects and hits the wall and then comes back to you without any time interval. And then also it hits the wall in all 360 degrees and all that, and it will come in and hit you. This is called the reverberation. And in the reverberation, we also find another term called echo. Echo is nothing but it's a similar kind of reflection, but with a time interval, right? For example, once I've seen in Kerala and all that, I've been there. So there's there's a place, it's like all hilly area and all that, all three sides hills and all that. So that one particular point where you go in and clap, or when you scream, or when you say hello and all that, after a fraction of a second, you will hear your voice again. So when you say hello, it will also say hello, 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 it will go on. So that is called an echo. So here echo is also a reflection, but with a time interval. A reverberation is a reflection without a time interval, whereas an echo is a reflection with the time interval in between. Now, this are the two important factors that we find in the acoustics point. Number one. Number two. So this one is basically measured by a unit called RT60, means reverberation time per 60 seconds. RT60. So, for example, I go to a venue, I go to a hall. When I say hello, or when I'm talking to a person, it is very reverberating, very noisy, and all that. So, what does it mean? It means that the reverberations are too much. So, how much of a reverberation do I have? So that refers to RT60. So let's say RT60. What's the RT60 value? RT60 value is, let's say, about 6 seconds, 8 seconds, 9 seconds, or 2 seconds. So sometimes it will be less than a second also. So that is an RT60 value, right? So another thing is that, for example, the sound which is coming from outside to inside, it's not that the sound which is there inside the room, but the sound which is coming from outside to inside, that we call it as an STC, or sound transmission class. So which means that, how do we understand the sound transmission class? For example, I drop a vessel outside, or somebody cranked the car, or somebody honked their vehicle and all that. So what is the sound outside, and then what is the sound intensity inside? How many decibels outside, how many decibels inside? So that is called the sound transmission class, STC. So one is a RT60 is the one which you will use to understand the how many seconds of reverberation we have, and the sound which is transmitting from outside to inside, it's called an STC, sound transmission class. This will be measured in the dBs. So RT60 is measured in seconds, STC is measured in the dBs and all that. Now, so how do we now? And then first and foremost thing is that this acoustics, how do we understand? So does every venue the sound the same? No. All the venues are very different. And what do we like? What do we don't like? Any reverberations which are coming to us with a later time, the more the time it is taking, the more the RT60, it will be more irritating to us. The shorter the RT60, we find it very pleasant. One of the reasons why people sing in the bathroom means the RT60 is very less, which means the distance from you to the wall is hardly about 3 feet, 4 feet and all that. So the sound hits that wall and then come back to you in a very quick manner. So you like that kind of a sound which has been there. But if it is taking more, for example, you are sitting in a hall and you're talking, it's about 30 feet away. All the walls are 30 feet away, 20 feet away, which means that it will go hit the wall and then create a big blasting sound, and then which will overlap the next conversation, or the conversation which is going on, or you're playing some instrument. The music is going on, so this is continuously overlapping that. It's becoming more and more and overlapping that we don't like it. That kind of a sound, we don't like it. So we don't like the reverberation, too much of a reverberation, we don't like it. So the RT60 values has to be minimal, less than 1 second, less than maybe a second, or 0.8 seconds, or that is a real good RT60 value we have to see. And what's an STC that we have to look for? Sound transmission class. For example, if somebody honks the car, when he's honking the car in front of your house, which is producing, let's say, about 100 and 110 dB outside. So what it should be inside? A good sound transmission class, it's about 25 dB, which means that if 100 dB is outside, which means you should be able to measure it inside 25 dB, which means it is very, very, very less, right? So that kind of an STC we have to look for. Now we find another, when it comes to the acoustics application, how do we understand? How do we understand that the application is good? When I go to a hall, I wanted to record the music with a small little band, and then I choose a hall. But how do I understand the hall has a lot of reverberation, or can I carry it on or not? Most of the time, the people go in and clap like this. They'll go clap and then they'll say, okay, it is too much of reverberation or something. Fine, clap helps you. But one of the easiest method for you to understand, this is a super technique. Take a balloon, blow it completely, about 12 inch. Take a balloon which is about 12 inch, it can be blown up into 12 inches. Blow it completely, fully, and then take a pin and then blast the balloon in the venue. So the blasting sound, you take a one of the easiest method to do it is take your phone. You have some recording apps in it. Keep that record button on. Take it on. Turn it on, and then you blast the balloon. Blow it, and then blast the balloon. And you see after that you can see it on the notes, that audio notes, or you can put on your DAW and then see how many seconds of that the tail or the reverberations are being carrying in the venue. If they are carrying for more than 1.5, 2 seconds or something like that, which means that that's the venue which is not really useful for you. You have to look for a venue which has a lesser reverberation. So this is an easy, super technique. You don't need to have an expensive microphones or measurement tools to do the job, softwares and hardware. It's an excellent technique which you can use for to understand that. And similarly, one of the super technique for audio recording is carry your phone when you wanted to record something on an outdoor or something somewhere. You wanted to go into the market to do a recce and all that. Carry your phone, turn it on, turn on the video or the audio, whatever you want to turn it on, and then keep it on as long as you finish your recce point and all that. Just keep it on, and then once you're done, bring it back and then put it on your headphones or put on your computer. Use a good headphones and then try to listen to it. You'll understand how much of a noise that this has been recording. How much of what's the sound? What's it been recording? So then meanwhile you keep talking. You keep talking. For example, two friends go to do a small recce of your small little interview that you wanted to do it, or small little shoot that you wanted to do it on the place and all that. So what you have to do is turn this phone on and then go into the venue, keep talking to them, and then discuss about multiple things. And then you come back and then you play it. If your voices are above those noises levels or above the ambient levels, it is good to go, which means that you are good to go for the shoot. If it is not that, if it means that ambient noise are too high, then it is dominating your voice, which is over dominating your voice, which means that you have to carry a special microphones for that kind of an application. So it is an easy technique to identify, okay, do I go with my phone recording? I can go ahead. Or do I carry a small little camera with a camera which is with a small little microphone mounted on that? That's a super technique. Your recce will really help you. Your phone can do that kind of a fantastic job. The smartphones are really, really smart nowadays. I mean, you can also download an app called Spectrum Analyzer, which will tell you about the amplitude, how loud it is going, and all the frequencies, how loud what kind of frequencies that you can hear, what the bass frequencies, middle frequencies, high frequencies, you can literally see on that. And then small little things like that you will develop. Now, in this process, after doing some kind of a recce like this and then going on for some time, you will easily develop an ear for this kind of a job. Next time you don't need to really carry your microphone. Next time you don't need to carry a balloon. Next time you don't need to really worry about, okay, do I carry an umbrella or not? You have to learn by listening and all that. I really encourage to do this. And then acoustics is very nice. It's tough, but it is very challenging subject, which will make you to do a lot of things and all that. But at the same time, as I was talking about this reflections in the room, let's say about so somebody was asking me last time also. I was talking to the Oxford University guys. So they were saying, what's the good reflection that we need, or do we have to have no reflections at all? I mean, zero reflections. I say no. Zero reflections is impossible. I mean, number one, it is possible only in a place called anechoic chamber. This is a chamber which is made with no reflections at all, zero reflections. Number one. Number two, from the time we are born, we are in a place where there are reflections. It's not that the place doesn't have any reflections. The place continuously having reflections. So we need to address that. It is not natural to have a place where there are absolutely no reflections. It's like a space that you can't find a reflecting sound. So we need to have some reflections. So what is the best reflection that we need to have? What is the time RT60 value that we need to have? I prefer it's about some 0.4 or 0.6 RT60. I mean, seconds of reflection that we find, 0.4 or 0.6 seconds of an reflections that we need to find in a place where we go. The moment we go, for example, the bigger venues, for example, you see big cathedrals, big churches, the big cathedrals, they'll have reflections about 2 seconds, 3 seconds. Even one of the fantastic cathedral reflection, they say it's about 3.2 seconds. So when I was doing some R&D work on the acoustics, when somebody asked me to look in for some of the reflections from this, we went to one of the big cathedral here in Telangana. It's called Medak. So the Medak, there's a big, huge CSI. You can see that Medak Cathedral. It's humongous, really, really good, fantastically constructed, and I think it's all about 100 years now. So when you go in there, when we went and then we went with the measurement microphones and everything. We did the same balloon test and everything. It is precisely 3.2 seconds. So these are the ones. So how does this work? So how does this 3.2 seconds work against where we are looking for 0.4, 0.6 seconds? The point here is the venue. The venue is, if the venue is bigger, yes, it is taking some time for that. The time it is taking for that is about 3.2 seconds. But if the venue is small and then still you have this, which means the reflections are strong, then you need to really address the small venues with too much of reflections inside. Now, so how do we choose what venue do I have to look for it? Number one, first and foremost, is how these reflections happen. The first and foremost thing is that reflections happen because of the hard surfaces. In a room, you'll find the cement plastering and then very fine putty and then marble and blah blah blah, all kind of coats that put on the tiles and all kind of things that put in the rooms that reflect the most. Glass is the biggest enemy to the sound. It reflects the sound the most than anything else. So any surface which has a lot of hard surfaces like this, they reflect the sound. The second thing is that, so whenever we have a construction or something to do, if you have an option to do it, do not construct anything which are in parallel walls. Something like this, like a box, don't do that. Don't prefer that for any recording and all that, because they create a standing wave. The sound energy hits here, and then in the center of the place, exactly the center of the place, you'll find a strong beam of sound which will be creating, and that's what we call it as a standing waves. Another thing is that one of the biggest problem that we find with the engineers, especially when they build this, they go with the ratios which are golden ratios, which looks aesthetically very nice, which means that the area, it, like for example, when they construct a room, they construct 20 by 40, which looks very beautiful. Oh man, 20 feet by 40 can accommodate things very well. And then he will show you this is the best place to do this design. All that is fantastic. But 20 by 40 is a wrong dimension for us. Rather, prefer a 20 by 30 or 20 by 35, 20, an odd number. It should not be, rather, in other words, how do we understand that? What's the ratio that you have to look for? Basically, you can look for the golden ratios or look for the ratio which is not a multiple of 2. So this one simple thing you have to understand. Any, for example, 20 multiply into 2 is 40. So don't choose 40. You have to be more than that. Don't fall into the segment of that multiples and all that, because that creates a harmony, that creates an overtones, and then you will end up again with a wrong, a lot of reflections and stuff like that. And cubes and spheres are really very, very bad for the acoustics. A place which is like a cube, like 20 feet by height and 20 feet width and 20 feet length, absolutely bad. 10 feet is really bad. Some people have seen, they'd like to do a small production in a small little chamber because they don't want to spend more money on the acoustics. They choose a small place which is 10 feet height, 10 feet wide, and then 10 feet length. Absolutely ridiculous to work in that kind of a places and all that. Avoid such kind of a places. So see that. So how do we understand that? Very simple. You take the length of a place and then multiply by 2. Go on multiplication by 2, and all that. So when you do that, you will find that the sound is not multiplied, or it's not been creating a harmony over there, and then becomes very strong, and then it becomes a very annoying thing for you. So to avoid, you need to avoid such kind of a parallel hard surfaces, the places within even numbers and all that. So try to avoid those kind of things to have a good response from the venues wherever you go. Another thing is that, for example, people have wrong notions. Many times people have wrong notions saying that, this is a good place. I mean, you can accommodate very good. You can accommodate a camera, you can accommodate this and that, you can accommodate good props in your setup, or you have been to a venue, it looks very nice, people can sit, accommodate, everything is really good, but it is reverberating. So people suggest, put some curtains. Just don't fall for it. what every time, for example, oh, we'll do some gypsum sealing. Gypsum sealing does your acoustics very well. It will control your sound. Don't fall for it. Don't believe it simply. One simple question you have to ask is, what is an NRC value for that? NRC means noise reduction coefficient. This is the term which we use for the absorption. How much of an absorption it can absorb. What is the sound, how the sound will be absorbed into it. So this is called noise reduction coefficient. So this noise reduction coefficient is the one which we have to look for. For example, I use a lot of curtains. I use nice velvet curtains. So what is an NRC value of the curtain, right? Or I use some gypsum ceiling. I use this ceiling. I use the marble flooring. I remove the marble flooring. I put a wooden flooring. So what is the NRC value of that? So whenever we do something like this, people say this, don't go by what they're saying. Ask for NRC value. Look for RT60, look for STC. These are the three things that you have to learn when you are working with an acoustically challenged places. So look for the sound which is the RT60 values are supposed to be less than a second, 0.6 to 0.8 at the max, and then your STC values has to be at 25 dB STC. It should not be more than that, so that you will find the sound coming inside and then creating a lot of noise, creeping into your recordings and all that. And avoid the parallel walls, avoid the hard surfaces, avoid the cubes, avoid the spheres, avoid the glass. These kind of things that you have to look for whenever you are shooting something, when you want to go on a shoot for some venue or something like that. Any questions on the acoustics or anything that we have to address more?
1 o'clock. Anybody would like to raise any question?
Father, I can't hear you.
Can you hear me now?
Yeah.
Okay. Yeah, perhaps we can, we could wind up. I think it's already 1 o'clock.
Yeah.
Madam, what do you say? Mhm. Can you hear me, Doctor
Yes,
Malika?
just I was not able to unmute myself. Yes.
Okay.
Yes.
Uh, Since there are no questions,
Anybody wants to ask something, or else I'll just see if our HOD is here.
yeah, okay. I think there are no questions. I don't see anybody asking.
But Father, what I suggest is,
Yeah.
Students, I mean, once they leave this session now, they
Yeah.
will have some questions, because this is what we've been doing with the JNTU, Oxford University, and some other colleges. What's happening is they will not be able to understand, because this is not the regular technique of teaching students. I understand this very well. This times, these webinars and all that are a little tricky, so we don't have the kind of a concentration like a class and so on and so forth. But even if they have a questions, I say that give me a time. I would like to take them on a studio tour, and then we will that time they can raise the questions, or they can shoot the questions now, or somebody can mail it to me or mail it to anybody, so that I can address those questions when we go to the next class.
Okay. We can think about it. Perhaps we can share it with the students. I think
Yeah.
that should not be a big problem.
Okay, Father, I think.
Yeah, thank you. So thank you, Hudson.
Father, thank you so much.
Yeah.
Thank
So
you,
maybe
guys.
that's,
Thanks, ma'am.
yeah, that
Thank
studio
everybody.
tour, we can think about it. We can.
Yes, Father. Yeah.
Okay, thank you very much on behalf of our department and our university. I think the students benefited a lot, and I mean, I'm not so much into audio and things, but I mean, I found it very, very interesting. So it was really a very good session, a very informative session, and we would definitely like you to address our students whenever you have the time in the future. Thank you so much. Thank you, Father.
Thank you.
And
Thank
thanks
you.
everybody for joining, HOD
Yeah.
sir and Jacqueline sir,
Yeah.
for all the help he's giving us.
Technical
all
help.
my,
Great.
Yes, Macklin sir, HOD sir, and everybody else who has supported. Also, Mr. Debbie Shaji and Dr. Joy, Anna, whoever has joined, all the participants, thank you very much.
Thank
Also,
you.
students, from Loyola College. Everybody who joined us, thank you.
Thank you.
Thank you, ma'am. Thank you.
Yeah,
Thank
and
you.
we meet
Thank
again. Yeah, thank you.
Thank you, ma'am.
Thank you, ma'am. Thank you, sir. Thank you,
Yeah,
Father.
thank you.
Thank you. Ma'am, you can close it, ma'am.
Yes, yes. We close it.
Yeah,
Thank you.
Yes, ma'am. Thank you, ma'am. Thank you. Yeah, ask the participants to fill that feedback form which has been already floated there, ma'am.
Okay, okay.
On
Please fill the
form,
feedback.
huh?
Some of them have
In the
left. I
chat box, feedback form is there, or you can just take that feedback form and you can share it with the participants to fill it.
Yes, sir. Yes.
In the
Yes.
chat box, there is a feedback form. Now you can just take it and you can send it to the participants. They can fill it out so they can get the certificate.
Okay. Thank you, sir.
Ma'am, have you taken that link, ma'am?
I'm not able to. Okay.
Now he has
Feedback.
shared it again. He has shared it again. Jerin K.
Yeah,
Dani.
yeah.
He has shared the link again. Jerin, he posted the file also. Yeah, both you can just download the text file which contains the link. You can share it. You can share it with your participants list, ma'am. Hello, ma'am. Can you hear me?
Yes, yes, yes,
Yeah,
sir. Yes.
yes, ma'am. Yes, ma'am. You can just
Okay, so
copy
you
that.
just
We will
fill the form. Just fill the feedback form.
the doc.google.com. That is the feedback form. They have to fill
Yes,
this particular
yes,
form so
yes.
that in another 2 days time they will get the certificate. Okay.
Okay. Please fill the feedback form.
Yeah. So I am just
Yes.
closing it up now, ma'am.
Yes, yes. Thank you, sir.
Thank you, ma'am. Thank you.